So what you'll be assessed on? Well, areas of all kinds: triangle, trapezium, parallelogram. You know where to find that in your book. That's the trapezium that I drew for you, and I projected it on the screen in school. Area of a trapezium is half AB times H, so the A and the B are the two parallel sides. That can easily be called B, that can be called A, doesn't matter. So the parallel sides are the A and the B, and the height is the height, not the slant. Slants don't work. I'll direct you to do some questions from exercise 3. That was a more tricky one. That's definitely in the book somewhere. And then after doing the basic areas of simple flat shapes, we revised areas of a circle and circumference. Generally, if you're given a radius, use 2 pi r to work out circumference. If you're given a diameter, just use pi d. But in both cases, and pay attention, the area is still pi r squared. You don't suddenly go pi times d squared if you're given a diameter. First divide by 2 to get the radius. It's obvious, but mistakes have happened in class, and unfortunately mistakes might happen in your assessment. There's just 2 demos I did, again taken from the book. I've been given a 9 centimetre, let's go large, shall we? I've been given a 9 centimetre radius, 2 pi r, there's your circumference. Work out the area as well, pi times radius squared, there's your answer. Please note the units are different. So if you're given a diameter, just use pi d to get the circumference. If you're now going to use this number to work out the area, make sure you divide the diameter by 2 to get the radius, and then go pi r squared, 3.14 times 9.1 squared, and there's your answer for that one. Very, very straightforward. It's only sort of low grade GCSE. Then it gets more involved, and I'm almost certain I did a video on this before we were locked down, but here it is again, just to give you an overview of what you're going to be assessed on. Semicircles. Trouble with semicircles is they're not whole circles, and there's nothing you can do about it. So first of all, if I want to work out the area of this shape right here, I work out the area of the entire circle, so it goes all the way around like that. And don't forget to divide by 2. It's going to be dividing by 2, you find the area of the semicircle right there highlighted. The perimeter is a much bigger pain because this is the perimeter. You walk around the semicircular arc, then you walk across the bottom as well. Okay, it's a semicircle. Don't forget to add on the base as well. So I went from the blue straight to the red. I've got to work out the circumference of the entire shape, and I'm given a radius. So I'm going to go 2 pi r, and there's my radius of 14. That's a radius here. I remember you didn't recognise that in class. I said, yep, it's definitely a radius, not a diameter. So there's your circumference. Divide by 2, 43.95, and just for safety, I'll put it on my diagram so I don't forget to add it on. So the 43.95 is the length of the semicircular arc. That's only part of the journey. You've got to walk across 14 plus another 14, hence adding 28 at the bottom. Is that all right? 71.95. Again, basic, probably up to grade 4, maybe 5. Next one, so quarter circles also exist. You know it's a quarter circle because it was probably very clear in the question, and just to emphasize it, I put in a right angle there just to emphasize that. So to work out the area of this space, work out an entire circle, and then don't forget to divide by 4 to get the, that should be squared by the way, but I can't make it fit right now because the area is in centimeters squared. Somebody right now should be telling me off, because you know I will be telling you off if I had the opportunity. Is this actually working? Yeah, let's go yellow. I've just spotted an error from, there you go. There never was a mistake. I would deny it. So quarter of the area of a circle divided by 4, there it is. Circumference is always going to be a pain because you've got to work out that little bit, and don't forget to add on the 4.2 and yet another 4.2 because that is the full journey around that quarter circle. So 2 pi r, radius is given to you. That's a full circle right there, divide by 4, and that's the quarter circle arc, so I've pointed to that. That arc is 6.6, so let's walk around the whole thing. So 6.6 plus 4.2 plus 4.2 comes to 15 centimeters, and many of you did that really, really well. But in in an exam situation, you may not be so chilled. So that's why I'm going over some of this stuff. Composite shapes. Well, these are bits of shape stuck onto other bits of shapes, much more complicated. I just want to refer to this, by the way, because this came up as an extension question in your book, and some of you did it, some of you did not do it. I recall the question. In fact, I can tell what the question is just by looking at what I've written there. You're given that the circumference of a circle is 8 pi in terms of pi. It's a non-calculated question, yeah? And you also know the circumference of the circle is 2 pi r. If 2 pi r is the same as 8 pi, you can set up an equation. You can cancel the pi's on both sides, and 2 times radius equals 8, from which radius must be 4. And now finally the question, what is the area of this circle? Well, I know he's got a radius of 4, and I know, this is me thinking big thoughts, bigger than myself, area equals pi times radius squared. So I'm going to put my 4 in the formula. A equals pi times 16, otherwise known as 16 pi. And please note, we've not picked up the calculator once, that's my old Casio, and went times 3.14. We didn't do that because at GCSE sometimes you get these things on a non-calculator paper where you're meant to leave your answer in terms of a multiple of pi. So I wanted to labour that for a bit. Back here, no, go forward. That's just revision for somebody personally. Again, you might recognise that little graphic there. Copied and pasted onto this. I've got to work out the area of that shape. Doesn't he mention perimeter? I don't think yet, but here's the area. Got a triangle there. There's the height. There's the base of 5, and you've got yourself a parallelogram. Now the 8.6 has got nothing to do with the height. The true height of the parallelogram is 7 millimeters. So you work out half BH for the triangle. You work out B times H for the parallelogram. Add up the 2 bits. That's why it comes to 50. Yeah. More complicated arrangement. We've got a semicircle stuck on top of a rectangle, and you've got to work out both area and circumference. Area and perimeter. Yeah, part for circumference up there shown. So let's do the easy bit first. Circumferences are easy. So I've got C equals pi times D. Where'd you get the D from? Well, it's going to be, let's have a look. Yeah, 3.7 across the base of this rectangle. That has to be 3.7 as well, logically. So pi d gives me 11.62. Halve it, because it's a semicircle, 5.81. The total perimeter is going to be your 5.81 plus your 2.4 plus your 3.7 plus another 2.4, take you back to the beginning, and there it is. Area, quite straightforward. The rectangle is just that times that. So that's, get that out of the way. Whole circle pi r squared, and the radius of course is half of this 3.7, which I've calculated right there as 1.85. So pi r squared, there it is. Don't forget to divide by 2 because it's only a semicircle. And now you're free to add the 8.88 for the rectangle, the 5.38 for the semicircle, and get your final answer right there. Okay. Again, this is in your book somewhere. I just want to talk it out and just highlight it. That's a more complicated thing, but a much better picture. Let's see where we're going. Let's go back in time. Let's just do this one quickly. I've got a semicircle stuck at the bottom of a beautiful parallelogram. I know it's a parallelogram because these little lines tell me so. Yeah, facing in the appropriate direction. So I'm going to work out the perimeter first. It's usually easy. So I've got a semicircle. The whole circle will be 2 pi r, and the radius is clearly 1.1. You can see the way it's positioned there. It is a radius and not a diameter, because that bit will be 1.1, as will that part. Okay, so 2 pi r, halve it, 3.46. In an exam, you should write this on your diagram, just in case you forget to use it in your calculation going forward. So 3.46. What about perimeter then? Well, it's going to be 3.46 plus a 9.3 going that way, plus a 2.2, plus a 9.3 coming this way, and we're back home, 24.3. Okay, looking at grade 5. Areas, not a problem. Work out the area of the entire circle, which is pi times r squared. Divide by 2 to find the area of just the semicircle, rather opposed to the whole circle that actually isn't there. So 1.9 meters squared. And then the area of the, no, that's too late. No, I might have been there. How do I not admit? I don't want to admit you. Right, so that's that. See, I lost concentration now. What have I got here? I've got pi r squared. I've done that bit. Right, the height of the parallelogram, it's not 9.3 times 2.2. It's an easy mistake to make. That is the slant. The true height is from there to the base, but take away the 1.1, because that 1.1 is just the height or radius of the semicircle. So to get the height, if I can draw it in crudely, I'll try. To get the height here, I want something like that, yeah? Again, really, really rough here. So I want to do 8.8 take away 1.1, which is where I got my 7.4 from earlier. So now I can do the area of the parallelogram. 2.2 is the base, and the height is 7.4, comes to 16.28. Don't forget to add on the semicircle, final answer 18.2 or thereabouts. All right. And then there's a bit of work on volumes of simple shapes, very, very easy, and surface area. I'm flagging this as stuff that you should revise if you've not done so already. Question 6 is an extension question on the surface area of the cylinder. I know some of you have done it, some of you won't have done it, because I wanted to move you on because it's very extensiony. I'm still going to test it though, but I'm just letting you know that you can research this bit yourself. Here's the next bit. So volume of the cylinder is quite special. You may recall that if you have a shape and you work out the face at the front, for example, triangular prism, you work out the face of the front, then you multiply by how deep it goes into the page in your book, then you've got yourself a volume. That's also true for cylinders, because you know that the circular top has an area of pi r squared, but that goes all the way down to the bottom of a height of h units. So actually the GCSE formula for volume is not pi r squared, get the answer, and then times it by h. Do it in one step. Volume is pi r squared h. Again, many of you have used the GCSE formula. And then we're on to Pythagoras and stuff, but we're going to do that next lesson tomorrow. So I'm encouraging you to revise everything up to Pythagoras, but don't actually do Pythagoras, because I want to say that for tomorrow, yeah? So that's enough. You've got a lot there. That's it. There's all this stuff on, enlargements and doing little construction lines through the vertices and that. I can't demo it on here. I know I taught you 1-to-1, so just watch out for that. There's some grade 7 on it as well. Check your books, do a couple of questions. But the revision's up to you, because the majority of you have done all of it, and some of you are well into the probability section of Unit 6, which we will probably finish this year anyway. No problem with that. All right, so I want to reduce this down.